In this video, we're going to continue to factor quadratics and solve for x. We're going to use a technique called X-box. And the reason we use X-box rather than just the X technique all by itself is if in our standard form here, if we have our standard form quadratic, if A is greater than 1, so 2 or more, we are most likely going to have to use the X-box technique. And I'm going to show you one example right off the bat here where it may look like an X-box based on this information, but we got to remember that first, always look for a greater common factor that you can take out of all your terms. And if you're still left with A being greater than 1, then that's when you use the X-box. However, if A is greater than 1, but it turns out that all of these terms have a greater common factor, and you take that out, and then A becomes 1, then all you have to do is your X technique, and you don't have to use this X-box technique. So that's why always check first for a greater common factor between all your terms. So let's try that out. In this example here, A is greater than 1. So our assumption is that we use the X-box technique. However, always check your GCF first. Well, as it turns out, all of these terms can be divisible by 2. That turns out to be the greater common factor, and we can take that out of each of these. So if I divide our first term by 2 or take a 2 out, x squared is left. If I divide my second term by 2, I'm left with x. And if I divide my last term, negative 12 by 2, I am left with negative 6. And again, you can distribute all the way through just to check and make sure you divided correctly or factored correctly. So now you can see that A right here is just 1. So we're only going to use our X technique. So 6 times 1 is, negative 6 times 1 is negative 6. Positive 1 is implied right there, so that's up top. So we need factors of negative 6 that add up to positive 1. Well, negative 6 times 1 doesn't add up to 1. Negative 1 times 6 doesn't add up to 1. Negative 3 times 2, that would give me a negative 1 if I combined and added those factors. So it's got to be negative 2 and positive 3, right? If we combine those, that gives us a positive 1. So those are what go in our parentheses, right? First thing that goes is the variable to the first power, then the sides of the x's. It doesn't matter which one. Put negative 2 in that one and positive 3 in this one. So that's how we factor 2x squared plus 2x minus 12. We take that 2 out. Don't forget about it, it's still there. That's pretty important. If we FOIL, we'll get back to this step. And if we distribute the 2, eventually we'll get back to the top. So it's a good way. You can always check your math as you go. Also, remember to solve for x. We want what x equals. We want where the parabola is crossing the x-axis. So we need to set our equation equal to 0, where y equals 0. And just ask ourselves, what's the opposite of what's in this parenthesis? Well, the opposite of negative 2 would be positive 2. If we substituted 2 for x, we would get 0 here, and then the whole thing would cancel to 0. That's what we want it to do. So x can equal positive 2, but it can also equal what the opposite of positive 3 is. So negative 3. So x, the x-intercepts, or x equals positive 2 or negative 3. So on our graph, the parabola is crossing the x-axis at positive 2 on the x-axis, or at negative 3. So 2 arms there. Alright, our next example, let's get into that X-box. Alright, let's try this example out. So again, check for GCFs. I don't see any greater common factors between all these terms. Now I'm looking at A. Is a greater than 1? Yes, so I must need my Xbox technique. So the Xbox technique tells us that we start with our x, and we do the same thing we did with the x technique. We're going to multiply c times a, or a times c, so 3 times negative 12 gives us negative 36. And we're going to put b up at the top, so positive 5. So we're asking ourselves, what are factors of negative 36 that add up to positive 5? The best way to do this when our numbers are big is to just go in order. Well, factors of 36 are 1 and 36. Let's not worry about positives or negatives at the moment. Let's just get some factor lists going. That's never going to add up to 5 no matter which one's positive or negative. 2 times 18, that'll give us 36. But is there any way that could add up or combine to make positive 5? No. Let's check 3. Does 3 go into 36? Yeah, it ends up going in 12 times. Does this add up? Is there a difference between these two factors of 5? No. Let's try another one. 4. 4 times what? 4 times 9. Well, that gives us 36. And if we make one of these negative, then they would combine to make a positive 5. So let's think about which one has to be positive and which one has to be negative. We want a positive 5, so we want the bigger number to be positive, smaller number to be negative, so that they multiply to get negative 36, but add up or combine to make positive 5. Excuse me. So we got half of it done. We're not going to be able to come up with our parentheses set yet. We need to do this box part of it. Alright, so we just make a box with 4 tiny squares in it. In this top left box, we're going to put the first term. So this entire first term, 3x squared. You always put the first term there. And then in the bottom right box, this last box, we're always going to put whatever c is. So negative 12. And then in the corner boxes here, the diagonal boxes, we're going to put the factors that we came up with, positive 9 and negative 4, but we're also going to attach the variable that we're working with. And that ends up being important there. So whatever variable you're working with, whether it's x or a or c, doesn't matter. Always attach it to whatever your factors are in those boxes. Alright, here comes the tricky part. We're going to GCF again. But we're going to GCF by rows and by columns. So we're looking up and down. We're just going up. And we're going to put that GCF up here. What's the greatest common factor between negative 12 and 9x? Well, if you know, it's 3. And we're going to do the same thing to this column right here. What's the greatest common factor between 3x squared and negative 4x? Well, really all they have in common is an x. What goes in between these two is whatever sign comes from this box. This is a positive 9, so I'm going to put a plus right here. Well, this ends up being one of our parenthesis sets. I can write that down here, x plus 3. And come up with our second set now by GCFing to the left. And the directions here are kind of important in that we can always take this sign and put it right there. And we're going to take the sign over here from this box. I'll come back to that in a sec. So let's go by rows now. So at the top row, what's the greatest common factor between 9x and 3x squared? Well, it's 3 and x. 3x goes into both of them. Take this sign that's right here. This is why the direction matters, because it's just more convenient. It's just right there. We're going to put a minus in between. And now we're going to ask ourselves on the second row, what's the greatest common factor here? Between 4x and negative 12. Well, it's just 4. So our second set of parentheses is 3x minus 4. And the order here doesn't necessarily matter. It might be better to put the 3x minus 4 first, but it really does not matter. If you FOIL, you should end up getting all the way back to the top. Let's do a quick check here. X times 3x is 3x squared. X times negative 4 is negative 4x. 3 times 3x is 9x, and 3 times a negative 4 is a negative 12. If we combine these middle like terms here, we end up getting a positive 5x. Well, that ends up being what we started with, so we factored correctly. So if we take our factor and we set it equal to 0, we can solve for our x-intercepts. What's the opposite of positive 3 here? Negative 3. And right here, you can either do it in your head or you can write it down real quick. We want 3x minus 4 and we want it to equal 0. How can we make it equal 0? Well, do a little bit of algebra here. Add 4 to both sides. That gives us positive 4 over there. And then divide by 3, so we end up getting 4/3. So x can be negative 3 or 4/3. If we were to substitute either of these values for x, we would end up getting 0. So that means these are the x-intercepts. The parabola crosses the x-axis at negative 3 and at 4/3, or might be easier to think about that as 1 and 1/3. So in between 1 and 2 there is where the other arm of the parabola is going to cross the x-axis. Alright, I'm not sure if we got time for one more. We can try, but this is a good introduction here. I'm going to do it slightly fast. Let's see what happens here. Here I'm going to combine a couple different things. Again, check your GCF first. Uh-oh, turns out that they do have a GCF. 4 is the biggest number that can go into each of these terms, right? So I'm going to take that out. So what's left over is 2x squared plus 5x minus 3. Well, after we took the GCF out, a is still greater than 1. So I'm going to still have to xbox this. So 2 times negative 3 on the bottom, that's negative 6. And b is positive 5. So factors of negative 6 that add up to positive 5. Let's see. 2 and 3 add up. How do they multiply to get negative 6 but add up to positive 5? That's not going to work. What about 6 and 1? Don't forget about that factor pair. Well, if I make this negative 1, then it adds up to positive 5. 6 minus 1 is positive 5. And it multiplies to negative 6. So there we go. We got what we need for our box. First term is 2x squared. Negative 3 here. Doesn't matter which one. Negative 1x and then positive 6x. GCF up. We just got 1. Here's our sign, negative. GCF up here. We get 2x. There's our first pair. Let's do the rows. Across, they only have x in common. The sign comes from here. And this is 3. So we got x plus 3. Again, don't forget about this guy right here. That still belongs down here. So this is our factored form of this quadratic. Let's solve for x now. How do we get this to equal 0? Well, we got two different things going here. We got 2x minus 1 equals 0, and we got x plus 3 equals 0. This one's pretty easy. We know that x is going to be negative 3 to equal 0 right there. Here we got to do a little bit of algebra. Add 1 to both sides, and then divide by 2, we get 1/2. So the x-intercepts are negative 3 and 1/2. The parabola arms are crossing the x-axis at negative 3 and at 1/2. Alright, so there was an example of the Xbox technique used to solve for x in quadratics. We got more techniques to come.